Three, two, one, mark.
Main operator. My sequence up 216.
In 2010, the Space Shuttle, after nearly 30 years of duty, will be retired from service.
The original NASA plans called for sail to be dismantled at the end of the Space Shuttle program. However, in 2011, Space Center Houston and Mike Coates, a former sail astronaut who was director of the Johnson Space Center at that time, decided to preserve key elements of the lab and add it to their tram tour for visitors.
I'm Don Magnusson, former manager of the Sail Laboratory. I was the operations and maintenance manager of the lab. We're here today, November 12th, 2013, 2 years after the shuttle program ended, 2 years after this laboratory was transitioned from its operational state to the museum state that it's in today. We're going to take a look at the lab today as it looks compared to when it was operational. The lab was operational in 1978 and supported all 135 shuttle flights. And then it was closed down and the transition effort began. NASA put United Space Alliance, my former employer, on contract to do this transition. So I had a team, I was the lead of the team, and I had about 30 USA employees working closely with the NASA facilities people, the electricians, the plumbers, the carpenters, and we all came together and converted the lab into what it is today. We relocated some of the equipment. A couple of the elements were dismantled. Downstairs in another area was the vehicle dynamic simulation. It was completely dismantled. Down the hallway here was the test operations center. It was also dismantled and repurposed. But we did bring one console in, and it's on display downstairs. We'll look at it when we get down there. So this effort took us about 6 months, and then Space Center Houston began the preparations, getting it ready for tourists. So we're going to walk through the high bay and look at the different elements. The cockpit is the centerpiece, still in its original location. The payload bay originally was covered, and our library and data office was located on top of the platform. But we dismantled the shelving, we kept the documentation, and that's on display downstairs in some of the cabinets. Then the platform was removed so you can walk around the payload bay from above and look down into it and get a better view. We'll take a look at all the elements as we walk through, but we're going to begin right here where I am right now in the Launch Processing System area known as LPS. So the consoles on my right are the original LPS consoles at the end of the program. Of course, LPS went through about 3 different upgrades during the life of the program. And these are the final configuration of the consoles when the program ended. This is where KSC came to test their ground software in this sail firing room. Now, a major addition for display purposes was added. Over here is a picture of the actual firing room at KSC with a video showing an actual shuttle launch. So that's a major addition to the lab for the benefit of the tourists.
We'll stand by here and see if the ring can resolve their issue, but we are go.
Okay, copy that, and we'll take it on down to 5 and see if we can't get there.
Yeah, it's a good plan, Mike. Let's keep going.
And KC Safe Condition Assurance?
KSC Safety Industry Insurance.
Let's see, if we get the go from SRO, you're going to be go. The firm will not re-pull you.
Mike, yes, we are good.
Right, so we will not re-pull you if we get a go from SRO.
That's affirmative.
Thank you, sir.
And OTC, OTCC.
OTCC, OTC, go.
My crew has arrived at the orbiter. Crew ingress and work at this time.
See that?
Okay, we're now going to start walking the second floor of the high bay, so we'll start off over here by the cockpit. I've walked into the center of the high bay, standing beside of the sail cockpit. The sail cockpit, being the centerpiece of the lab, was preserved exactly like it was in the operational days. All of the instrumentation and switches, displays and controls and the panels are still inside the cockpit. The hand controllers, the seats, just like they were the day we walked away from the final test. Outside, you can see the number of the vehicle, OV-95. Sail had its own tail number, OV-95. You can see the forward scene, the overhead scene, and the aft scene, just like it was in the operational days. We did add this board here, this picture, this display that has the sail patch, along with the signatures of many of the sail people that worked here over the years, including astronauts. Now we're going to move over and take a look at the payload bay. As you might remember, the payload bay was covered. There were cabinets located here which housed the sail library and data office where we stored all of our test data. It was decided to open the payload bay up so you could get a better view of the wiring. So we removed the cabinets, maintained the documentation downstairs in some of those cabinets, which we'll take a look at later, and remove the floor so you can get a good view of the inside, the vast size of the payload bay and all of the exposed wiring here. In a real orbiter, of course, the wiring is covered with thermal blankets and you can't really see it. But we left it open here in sail because it would better fit our purposes for testing. The room in the center there on the bottom floor was added for the benefit of the tourists that come into the lab. They can walk into the center of the payload bay and look around and get a feel for the size of the payload bay while they're behind the glass walls. So normally the tourists do not come out into the payload bay, they stay inside the glass room. From here, we'll go back to the back and take a look over the top of the aft avionics room behind the big picture of the OMS pods and the vertical stabilizer there with the engines firing. So we'll come back here, take a closer look at the back part of the bay. The American flag is still mounted. We put that flag up about midway through the program, and lots of people have commented about the flag. That was an addition that we made when we were operational. This picture was added after we ceased operations, which gives you a better view of what the aft part of the vehicle looks like, since in sail we did not have the vertical stabilizer or the wings or an actual remote manipulator arm, which is shown there. So this just kind of completes the picture of the vehicle. We're going to walk up the stairs here and go back behind the picture and take a look at some more equipment back here. We're now standing over the aft avionics room down below, and we'll go down there later on during the tour. But I wanted to show this equipment here that was actually located right here during testing. This is the engine sensor simulator in its original configuration with the doors removed and this plexiglass panel put up here so that you can see the internal workings of the equipment. This stand was the stand which housed, or which the main engine controller was mounted on, a big black box that was mounted here, but it was located down below, but we decided to move it up here. And then the controller was sent back to Marshall Space Flight Center to be repurposed on other programs, on follow-on programs for the shuttle. So we don't have the engine controller here anymore, but this is the stand it was mounted on. This equipment is the separation simulator that simulated the umbilicals between the orbiter and the ET, and the ET and the SRB, and the orbiter and the ground. So this is called the separation simulator. It was actually located 180 degrees over here. We just turned it around and left it in this position. So next we're going to go back down to the port side of the vehicle and take a look at some of the equipment over there. These cabinets house the avionics that was the actual flight boxes that were mounted on the solid rocket boosters, the integrated electronic assemblies, two here, rate gyros, range safety equipment. So we relocated this equipment and preserved it out here for tourists to be able to look at. We took the front doors off the panel and replaced them with a plexiglass so you can see inside. Moving on down, here's the rate gyros I mentioned, the range safety equipment, and some power supplies that power some of the equipment. And we'll move on down a little further, take a look at this piece of equipment here, which was brought in from another lab. This is actually a test console that was brought in from the JAIL lab, the JSC Avionics Engineering Lab. This was a console that was used to test the new GPCs, the new general purpose computers, which are actually mounted in here. If you take a closer look, you can see all 5 computers. These are the newer version of the computers that were tested in this console located downstairs, but it was interconnected to the sail vehicle when we did that testing. So from here, we'll move on over and take a look at this part of the lab. This was known as the SATS, the Shuttle Avionics Test Station. Of course, it doesn't look the same today as it did when it was operational. We accessed some of the equipment, but we preserved some of it, like the operator console, the recording system that recorded data in the vehicle. So this area was known as the SATS. From the SATS, we're going to move on over past the entry door here and take a look at this console here. This was the MEDS test console, the multi-purpose electronic display system. You can see mounted in here the cockpit displays. These are the 11 flat screen liquid crystal displays that are actually mounted in a cockpit. There was a set on this console for testing of that upgrade to the vehicle avionics, and this console was also located downstairs in the JAIL lab where the GPC test console was. So that was brought up as an addition to the lab. From here, we're going to move around to the starboard side and take a look at some more equipment over there on the other side of the high bay. This blue cabinet simulated the forward RCS system on the vehicle, the forward ROS. So it was actually located out in the center of the room there, but we moved it over to the side and placed it alongside the other console, which was the mass memory unit simulator, which held the flight software before it was loaded into the flight computers for testing. So that's the mass memory simulator, the forward ROS. From here, we're going to move back alongside the starboard side of the vehicle and take a look at some equipment down this wall here. There's the jail emblem that goes with some of the jail equipment I talked about earlier, the JSC Avionics Engineering Lab. That was brought here for display. This was our sale timeline that was created back about mid-program that shows the progression of the lab from initial concept and build up all the way down to the end of the program. And swinging around back across the high bay, we're standing on the starboard side of the cockpit, OV-95 again, looking at the scene equipment, just like original configuration when it was operational. Of course, this railing was added for the benefit of the tourists to keep the traffic flow in a safe manner. The tourists are not allowed to go into the cockpit. It's a bit of a chore to climb the ladder and get up into the cockpit. So you can stand here and get a good view inside the cockpit, but for the tourists to be able to see what it's like in the cockpit, this display was created, which gives you a virtual tour of the cockpit. What you're looking at here is a view that's panning around, and I can actually move this display, swinging the camera on around to the commander's seat. And here we're looking at the forward display panels, the rudder pedals below, the center console, and here is the pilot's seat. And the video actually swings down, and you see the floor you're standing on, or you can swing it up and look overhead at the panels overhead, and again back to the aft. Kind of makes you seasick when you're moving this around, but that's a virtual tour of the cockpit. So from here, we're going to move on back and take a look at this display on the wall that was added. This thermal blanket, this is an actual thermal blanket. This actually flew in space on orbiter Atlantis. The lettering, United States, and the flag and the thermal blankets were removed from Atlantis in 1997 during a major modification of that orbiter, and they brought it here and put it on display here. So that's a piece of actual flight. I don't know if, I guess it's software. It's not hardware, firmware, or software. It's a thermal blanket. Okay, before me here is the stairway that leads to the first floor. So when the tourists come in from outside the building, they come up the stairway here, come up to the top of the landing here, and this is your first view of the expanse of the payload bay again and the high bay of the sail lab. There's a video monitor mounted here over the payload bay. And when it's running, there's a video tour of the lab, the sail logo, that the tourists are able to stand here and view. There's the sail patch.
A space mission never actually took off from a launch pad. It was here, inside Building 16, in the Shuttle Avionics Integration Laboratory, or SAIL. The shuttle before you, a simulator with the official orbiter vehicle designation, OV-95, has flown every single shuttle mission from pre-launch to post-landing right here in Israel. The SAIL facility contains 2.5 million parts and includes a high-fidelity cockpit, a 60-foot-long payload deck, 230 miles of wiring, advanced computer systems, and 1,750 black boxes. All of these components are exact replicas of the equipment on an actual flying orbiter and can accurately simulate an orbiter's response to computer system commands. The shuttle was the first ever crewed spacecraft to fly in space without a single unmanned launch or orbital development flight, a feat that would...
Okay, we're going to move on down and take a look at this equipment here. These power supplies are what powered the vehicle when it's on the launch pad before we actually do a simulated launch and the vehicle is in flight. So these ground power supplies, known as the T0 power supplies, there's 3 of them. There's 3 triple redundant power in the vehicle, so there's 3 ground supplies that feed power through the T0 umbilical simulator here. And there's a poster that we added here that explains it in more detail. So that's for the benefit of the tourists. And throughout the lab, you'll see signs like this that explain in more detail the purpose of the equipment that it's mounted near. From here, we'll go down the steps and start walking around the first floor and take a look downstairs. We're now down on the first floor in Building 16, the sail lab. We're still on the starboard side of the vehicle, so we're going to walk around here and look into the middeck, take a closer look at the inside of the middeck. The original configuration, there was a plywood or a walled-in solid wall across here with an opening right here for an access. But the wall was cut out and the glass was added all the way around so the tourists can walk around and get a really good view inside the middeck to see all the avionics and the wiring inside. Again, the tourists are not allowed into the cockpit or middeck. They have to stay out here and look inside through the glass walls. And this poster was added to explain what went on here, what's inside the middeck. So that's a good added feature for the benefit of the tourist. We're going to go on around the front of the orbiter and walk around over to the port side and keep looking at other equipment. Now, as we pass around here, there's other equipment located over here. Here's a big picture board of sail personnel. There's sail people. There's the cockpit with Mike Coates in the left seat, Bob Winkler in the right seat flying a simulation. There's Dennis Butler over there, other pictures of sail people. And then behind that, there's some other equipment which we'll talk about later. We're here in front of the vehicle, out in front of the nose, about where the nose landing gear would be. Again, the solid walls were taken down and the glass put up so you could see inside, get an inside view of the forward cockpit area. This equipment was the T0 umbilical simulator. This is where we patched the data that flowed from the vehicle to the ground recording systems and the commands from the TOC or the LPS over the launch data buses into the vehicle. So this was our big patch panel that patched all the telemetry data and the launch data bus commands to the vehicle through here. Moving on back, we're on the port side now, again looking into the middeck through the glass walls. Tourists are able to come up here and walk into the little alcove there and get a closer look inside. And the only access to the flight deck was up that ladder there on the right side that is coming into view right now. There was a stairway here where we were standing that took you up into the middeck, and then you had to climb the ladder up through that hatch to get into the cockpit area. Next, we're going to go back alongside the payload bay and go through the entryway down there and actually step inside the payload bay. Again, you see lots of glass walls that were erected to keep the tourist in the right spots out of certain areas that it would be unsafe for them to go into. But here's a little glass room that is open for tourists to walk inside. So let's step inside and take a closer look. So now we're standing inside the payload bay, looking to the aft of the vehicle. Again, there's the American flag on the aft 1307 bulkhead. Another poster that we put here explaining the equipment you're looking at. Swinging on around, you can get a good view of all the wiring, the size of the payload bay, which is actually 65 feet long and about 20 feet wide. This door normally remains locked. So tourists are not allowed to walk inside beyond this point. NASA did make arrangements for what's known as a level 9 tour, where you have to pay money, extra money, and get a personal escorted tour through the lab. You can get inside the payload bay and actually climb up into the cockpit on that level 9 tour. But that's not open for the general tourist traffic. So from here, if you'll look up overhead, you can get a sense of how big this vehicle is and how big this high bay is. We're going to leave the payload bay now and go back outside and take a look at the remaining part of our sail library and data office, which was previously on the second floor sitting over the payload bay. We moved a lot of the equipment or the cabinets down here, and the actual engineering drawings and documentation that was used to build and maintain the lab are still filed here, locked up in these old, antiquated government-issue gray cabinets. And the poster board above explains that in more detail. From here, we'll go back to the front of the vehicle and look at some of the other equipment that was brought in from the jail lab. We're still on the first floor in the sail lab. I'm now moving around to the front of the cockpit area. Operational days, this whole area was full of cabinets, consoles, the test operations center, operators sat down here. And this was kind of like the back room for the test operations center main consoles, which were upstairs in a different room. As I mentioned earlier, most of those consoles were accessed. However, we did convince NASA to keep one console for display. So this is the test conductor's console. The RTC console, which stands for, originally was the Rockwell Test Conductor, which later became the United Space Alliance or USA Test Conductor console. And then on the right is the QC console. These were originally located upstairs in the other room, but now they're here for display. Okay, moving from here, we'll go on over to another area to look at these cabinets, which are the fuel cell power supplies. The orbiter itself has 3 fuel cells for power, as shown in that picture on the wall there. And the sign explains the simulation of those fuel cells here in sail. We had 3 laboratory type 500 amp 28 volt DC power supplies that simulated the fuel cells and powered the orbiter. Moving on over here, we have a couple of other cockpits. Now these two cockpits, actually it's one cockpit that's been split in half. This cockpit was not part of SAIL originally. This cockpit was located over in a sister lab called the Shuttle Engineering Simulator, SES lab, which was in a different part of the building. But rather than excess these, NASA decided to preserve them and bring them in here. We had the space available, so they're set up here for display to show engineering simulation testing versus SAIL verification testing. That was the primary purpose. Engineering testing versus SAIL verification testing of the flight software. Now, as we go on around the corner here, we have a huge SAIL logo that catches your attention when you come in the front door down there. So that's on display. That was our SAIL logo throughout the program. Okay, I think we're now ready to go back to the aft base, so I'll go down this long hallway and enter the aft avionics room where there's lots more avionics and wiring of the shuttle. We're passing the mid-deck and the stairway that goes back up to the second floor. So the avionics bay is all the way in the back. I've just walked the entire length of the lab of the vehicle from the nose to the tail. We're now at the aft avionics room entrance area. But before I go into there, I wanted to point out this piece of equipment here. This is the aft ROS, aft RCS OHM simulation, still sitting in its original configuration when it was operational. And from here, we'll go into the aft avionics room. This is actual location, actual size on the orbiter. However, a real orbiter would have lots of plumbing and piping running through here, transferring propellants to the engines and so forth. But in SAIL, we math modeled all of that, and what you see are the primary avionics bays 4, 5, and 6, and all of the flight wiring, plus laboratory wiring that's interconnected to the ground simulation part of the SAIL lab. Overhead, one major change from operational days, we removed the second floor. There was a ladder here that you had to climb to get up on the second floor, and we had the shuttle main engine controller mounted on the test stand up there, along with some power equipment, and that was all relocated to the top floor, which we saw earlier. So the second floor was removed to make it more visible, give the tourists more visibility into the back room here. Here is the Shuttle Avionics actuator simulator, the SAS. Shuttle Aerosurface Actuator Simulator, which simulates the aerosurfaces, the elevons, the body flap, rudder, and speed brake, still in its original location. So from here, we're going to move back outside to the starboard side and get ready to exit out the side door of the building. I'm now walking back towards the exit doorway. Actually, it's an entry and exit doorway. As I approach that point where the tram tourists come through, the first thing they see as they come into the lab is the name of the lab, the Shuttle Avionics Integration Laboratory, the big sign here that has the name of the lab. Over here, this display shows one of the flight computers that flew on the shuttle, that control the shuttle in flight. There were actually 5 of these computers, and this is one of the original computers, the 2-box version, the CPU and the IOP version of the original flight computer. One of the first things the tourists see as they enter the lab, which is kind of the key heart of the testing operations that we did, is testing the flight software that was resident in those computers. So the doorway to my left, again, this is where the tourists come in and out now, so I'm going to walk through here on my way out of the building. I'll just stop here briefly and explain this room originally was the flight system shop. This is where we had anywhere from 10 to 20 technicians working in this shop. It was full of workbenches and tools where the technicians did all their work, building boxes and wiring and soldering, etc., to build and maintain the lab. So this was the original flight system shop. It has since been cleared and turned into a reception area for a large group of tourists as they come through the door over there off of the tram. So the tourists come through here first, and the tour guide gets on the PA system and introduces them to the lab and explains about what they're going to see in the lab. And then there's a video that plays up here, and the title is called The Necessity of Simulation, a really good video that explains how the sail lab fit into the shuttle program. So now as I approach the exterior door here, I'm going to step outside. This is the doorway that leads from outside into the lab. The tram comes through the parking lot, stops here, tourists get off, they come through the door, take the tour of the lab. It's about a half-hour tour, I believe, and then they come back through here, get on the tram, and go to other facilities. So that basically completes the tour of the lab. I would like to encourage all of you to come out and see it for yourself. It's really a neat display. We've done a lot of work. The USA employees that were here to the end did a lot of work bringing the lab to this state. So everyone is encouraged to come and see it for yourself. And that concludes the tour.